Hello, I'm Peter McBride from Mixergy, and I'm the National Business Development Manager responsible for new build and the decarbonisation of the existing housing stock for large housing providers. I'm here today to talk to you about Mixergy Smart Hot Water. So if we have a look at this slide, we can see, there's a lot of stuff here that's not particularly new to everybody. We know we need to phase away from fossil fuels. We know we need to protect households from fuel poverty. We also need to obviously provide thermal comfort. But there's a couple on here which are not necessarily widely known within the industry. And this is the manage the greater renewable energy capacity coming online. And the bottom right-hand one, which is to address the grid constraints due to the electrification of heat and vehicles. So in very simple terms, the electricity grid was not initially designed for the electrification of heat and the electrification of vehicles. We do not have the time and we do not have the capital to upgrade all of that infrastructure. So we just have to do things a little bit differently. So before we talk about Mixergy, I think it's always worthwhile just recapping on a traditional cylinder. And here is a typical traditional cylinder. And what you can see is we have the heat sources positioned down below. So we've got the coil, which will be predominantly connected to a gas oil boiler. And we have the immersion heater. So very similar to what you see in the bottom of a kettle. And irrespective of that tank volume, whether that's 100 litres, 200 litres, 300 litres, it makes no difference. You have to heat everything on the thing. There is absolutely no in between. What Mixergy have got is we've got sensors that run the whole length of the tank. And these tanks are connected and they're live and they feed back live data. And we've been able to identify that on average, people actually only utilize approximately 50% of the tank volume. However, with a traditional cylinder, we're having to heat up all contents. So a traditional cylinder has a very rudimentary control system. It's on and then it's off, and that is fundamentally it. There is nothing more it can or cannot do. With the Mixergy tank, the first thing you'll notice is the heat sources are now moved to the top. So we can now see the immersion heater and the coil. What we can now do is we can now volumetrically heat, so we can heat from the top down and heat what you require and not necessarily the full tank contents. And we do that through a number of means, really. So we do it by, firstly, you clearly need to have the heat source in position at the top. Like I mentioned, we have the sensors that run the whole length of the tank, so we're able to understand what's happening inside the tank. And if you have a look here where we've got the vague yellow line, that is a term what we call the thermocline. So this is not a part that Mixergy has installed inside the tank. It's a natural occurrence in water. So if you've ever been near a lake or a river and you've put a body part in and it's gone arguably warmish, then all of a sudden fairly cold, that's because you've physically broke that thermocline. We are able to control that thermocline. So by keeping the thermocline nice and crisp, you can keep hot and cold water separated. If that thermocline destabilizes for any reason, the hot and cold just dilute into each other. So in this particular scenario, the tank is heated to 20%. If I wanted to increase the volume of hot water to approximately 50%, the way I would achieve that is by physically pushing that thermocline down and using the tank essentially like a battery. And the way we would physically get water into the top would be via what we call the top-up pump. So the top-up pump will suck water from the lowest part of the tank through an internal pipe into a diffuser. What we then do is we atomize the water. So we spray cold water into the already body of hot water at the top. The reason why we spray it is because it attains the same surrounding temperature instantaneously. If I were to pour cold water into the top, it'd be very similar to what you do with a cup of tea or a coffee. If you pour cold water in, it just dilutes it. So that is fundamentally how Mixergy is able to heat from the top down and heat what you require and not necessarily the full tank's contents. So there's a typical example of the Mixergy tank. Looks very similar to most other tanks, and that's because fundamentally it pretty much is. All the clever stuff is on the inside with regards to the technology. What that also means is anybody who is G3 certified, which is the qualification required to install, service and commission vetted tanks within the UK market, are able to install, service and commission a Mixergy tank. There is no real difference. Some top level figures, we can deliver hot water up to 10 times faster than a traditional tank. We could deliver 30% more usable hot water compared to a traditional tank as well. And we've got some thermal imaging which will demonstrate that. We can save up to 40% on a hot water energy bill. And if the tank was connected to a gas or oil boiler, we can reduce that fuel consumption, i.e. gas or oil, anywhere from 12% all the way up to 21%. So there's various ways to control the tank. We have the app, we have the gauge function. It can be integrated with smart time of use tariffs. We have machine learning, we have voice control, and we also offer cloud connectivity, which gives us free software firmware updates. And we can also actually do remote diagnostics as well. So we're very often able to remotely log into the tank understand what the issue may or may not be, and we're often able to diagnose it and repair it. And we're also able to identify whether it's actually the primary heat source, which could be a gas boiler, heat pump, for example, that is not heating the tank. So that wastes downtime of waiting for a mixture engineer to potentially attend to then say you actually need your manufacturer for your primary heat source. So when you connect the mixture tank to a heat pump, every tank comes with these two ports, which we call the heat pump ports. If you were to connect the tank to a heat pump, then you would buy this accessory module, which is what we call the heat pump module, which consists of a plate heat exchanger and a pump. A couple of key benefits of the mixture tank compared to a traditional heat pump cylinder is with a traditional heat pump cylinder, the coil will predominantly run the whole length of the tank. So it's a very large coil surface area. With the mixture, because we utilize an external plate heat exchanger, we don't have that internal coil, which means where they would have a physical coil, we would have hot water. So we can actually deliver 20% more hot water compared to a traditional tank. We're also able to boost the coefficient of performance in hot water mode by anywhere between 5 and up to 10%. Our tanks are very compact and typically 40% smaller than others on the market. We also offer slimline models. And this one here, it says better heated of the full contents of the cylinder to the same temperature. What that's alluding to is a traditional cylinder would have a sensor probe positioned approximately here. And let's say that's set to 50 degrees for argument's sakes. What you'll find is around the probe, the temperature will be fairly accurate. Below the probe and above the probe, you will have some temperature disparity. With the mixture tank, if you select 50 degrees from 1% right the way throughout to 100%, the tank will be at 50 degrees. This then brings us on to lesion-led pasteurization. So lesion-led pasteurization is a relationship between time and temperature. And essentially, because a traditional cylinder is unable to accurately measure the full tank's contents, when they are trying to achieve lesion-led pasteurization, they often go to 60, 65, sometimes even 70 degrees. And it does differ by manufacturer. However, mixing, we are able to achieve lesion-led pasteurization as low as 51 degrees. And the reason why is because we know for a fact we've held the whole tank's contents at 51 degrees for the time period required to ensure we've achieved pasteurization. So we can achieve the same end result utilizing less energy, which obviously results in a lower carbon impact and a lower energy bill. We are seeing more and more homes now utilizing technologies like solar PV. And the mixer tank works very well and in harmony with this solution. So what we have is we have the mixer tank, we have the Cat5 cable, which goes via a CT reader and the CT clamp onto the incoming neutral. What this is then going to do is going to monitor whenever any energy is about to go back to the grid. So with solar PV, it's always going to be generating whatever it's generating, and it's always going to prioritize the house first. What then happens is if it gets to a stage where the generation exceeds the usage, you either have to send it back to the grid where you might have an export tariff, which you might get paid a certain amount for it. Generally, there's not often that financially beneficial, or you can store it in some sort of a means like a battery or like what we do with the mixer, which is a thermal battery. So what we have here is we have an immersion heater. So that's a 3 kilowatt immersion. And essentially what can happen is as soon as anything from as low as 1 watt all the way up to 3,000 watts is about to go back into the grid, our immersion heater will then say, no, you're not. And then we'll be able to divert that energy into the tank. So every watt of energy I put into that tank will become instantaneously 1 joule of hot water. And the whole ethos of this is to essentially try to heat that tank as much as we can through solar generation, which means there's no carbon impact, and because it's coming from the sun, we're not importing any energy from the bill from the electricity grid. We have the SAP Appendix Q accreditation, which essentially understands and recognizes how well Mixergy is able to volumetrically heat and how well we're able to utilize any excess solar, which would normally go back to the grid and store it into the hot water cylinder. We use the tank essentially like a battery, so you can actually change the temperature set point. So previously I mentioned that we might have the tank set to 50 degrees. What you can say to the tank within the settings is essentially, if there's excess solar, I want you to change the temperature set point from 50 to 60 degrees, and essentially try to heat the whole 100% contents of the tank. So you're basically using it like a thermal battery. So to control the tank, we have an app. We have a gauge. So here's the gauge here. Each LED represents a 10% volume of the tank. This is telling me we have 40% hot water, 40% cold water, and someone has pressed the boost button twice, which is represented by the two greens. Once each green turns red, it then means the tank's reached whatever temperature they've set the hot water to. It can be utilized on a desktop or a laptop, and it can also be operated by smart speakers. So the tank is very easy to operate. So going back to a couple of slides in when I mentioned we can deliver 30% more usable hot water compared to a traditional cylinder, and here's the evidence here. So what we have is we have a 180 litre Mixergy tank at the top. We have a 180 litre traditional tank at the bottom. Both of them have been heated to 60 degrees. Both of them have then had 60 litres of water discharged at the same temperature and the same flow rate to represent a more traditional shower length. And as I'm sure we're all aware, as hot water leaves the tank, cold water comes in to replenish this. And if we look at the bottom tank here, as that cold water comes in to replenish it, it massively comes in and swirls around and dilutes what's already been heated. So if we look at this image here, this is a 180 litre cylinder. We've only actually discharged 60 litres, but you can see how much is actually diluted the vast majority of the tank's contents. It's worth bearing in mind as well that with a traditional cylinder, you do not have a gauge, you do not have an app which shows you what your current status within the tank. So in reality, people probably best press boost again to heat that tank again. Whereas in the Mixergy, in the same scenario, as the hot water leaves the tank and the cold water comes in to replace it. Previously, when I said we control the thermocline and push the hot water down, we do the reverse with the cold water coming in. So as the cold water comes in, we don't enable it to massively swirl around and dilute. It fills up very slowly from the bottom and preventing that dilution. So again, if we look at the end figure, this is a 180 litre cylinder. It's had 60 litres discharged, and you can see how much more hot water we've actually retained. So generally, we would prevent that tank from having to be reheated again. The impact this has is you're able to essentially go down the cylinder size. So let's say you might have a house type now that requires a 250 litre cylinder, a traditional cylinder. You could fit the Mixergy 210 litre cylinder. And that end user will have absolutely no impact on their usable hot water. So in reality, the Mixergy 210 delivers the equivalent of 273 litres of hot water. So we have machine learning as well. So we have three settings for machine learning. We have off. So that's where you will tell the tank how much you need. So you might say to the tank, I want you to heat to 50% in the morning. You might then say, I want you to maintain between, say, 10 and 15% throughout the day. So there's always enough for hand washing. And then you might say heat back up again to, say, 50% of the evening time for an evening usage. Or you can utilize the machine learning with, we have two settings, economy and standard. So economy will say, for instance, I use 100 litres of hot water for a shower. The tank will make sure that it heats me 100 litres of hot water. Or if you utilize standard, it will say I use 100 litres of hot water. It'll give me a 10% buffer, so it'll ensure that the tank heats 110 litres in case I decide to stay in a shower a little bit longer than usual. What we have in the UK is generally people have either had instantaneous combination boilers, which basically means if you run a hot tap, it's going to give you hot water 24/7, or they've had cylinders that heat everything and nothing. And what that means is people tend to overestimate how much hot water they actually require. So if we have a look at this example here, here's an actual Mixergy tank. This is a 2-week period where the customer has set up a schedule, and we can see on average how much kilowatt hours they've used. If we have a look here, the tank used on average 5.28 kilowatt hours every day. The tank for 2 weeks monitored this customer's usage, so every minute and every litre that was discharged from that tank. And then essentially it started to paint up a bit of a usage pattern. And then after 2 weeks, it had enough data to be able to make an amendment, and it reduced that hot water usage down to 3.33 kilowatt hours per day, which is a 37% decrease in energy. And this is not about them jumping in and out of the showers quicker. This is the tank essentially saying, for example, you've been heating 150 litres every single day. You only actually require 100 litres, so I'm going to heat you what you need. So there's some big savings to be made. Right, with regards to the grid capacity and load shifting is going to become very important. So at the moment, we still utilize gas to produce about 40% of our electricity on average. The UK strategy to decarbonise the electricity grid by 2035 will be mainly by wind turbines and solar PV. Hydro, hydro, and also nuclear will play a part, but it's going to be essentially nuclear. It's going to be essentially solar and wind turbines. And the difficulty you have with them is they're an inflexible energy source. So we cannot make it sunny. We cannot make it windy. It just happens when it happens. So if you've ever driven down the road on a motorway, for instance, and it's been a windy day and you can see wind turbines are not spinning and wondered why, that's because at the moment within the UK, we spend an astronomical amount of money every single day turning off these assets because they're producing too much energy. So very similar to what I said previously about our solar in our homes. You either use it, store it, or essentially it's wasted. And that's very similar to a larger grid scale. So essentially the grid has to work within a fairly narrow bandwidth with regards to hertz and voltages. And as we have renewable energy coming onto the grid, that actually increases the hertz and voltages. And if we cannot allow that to get too high. Otherwise, it just destabilizes the grid. So what happens is we either have assets that is able to store that energy when it's being used, or we essentially pay for them to be turned off. So what we have here, we have a 24-hour time period. We have the percentage the tank is charged, and we have the price of electricity per kilowatt hour. So approximately 4 o'clock in the morning, the price of electricity plummets to a negative. What you find is when there's another generation of renewable energy, the price of that energy is often reflected. In the same occasion, the Mixergy tank turned itself on, and it went from approximately 55% charge to about a 90% charge. If we look at the bottom graph, here is the same 24-hour time period. Here is the watts consumption, and here's the carbon intensity across the day. If we have a look here, this is when we took the energy. We can see we've taken the energy, essentially the lowest part of the carbon intensity throughout that period. And between, approximately 4 or 5 o'clock in the morning, that's clearly not the sun. That's been wind. So what's happened? There's been a sudden gust of wind. All these wind turbines are starting to spin. The price of electricity has plummeted, and our Mixergy tank has been able to recognize this and essentially offer the grid what is known as demand side response, where it helps absorb that energy. Throughout the day, there was some solar generation. And again, at the same occasion, our tank took some of that energy. Going back to the grid constraints, at the moment, we utilize approximately 5% of the grid's capacity off peak, and we utilize, or we sometimes come dangerously close to the grid, almost destabilizing it at peak rates. And as we interject more and more technologies like heat pumps and panel rads and infrared, for example, and electric vehicles, what we need to start doing is we need to start load shifting. So essentially, if you've got, for argument's sake, about 5% usage here compared to about 95% usage here, clearly that we don't en masse have to upgrade all of that electrical infrastructure. What we need to do is we just need to start balancing out the peaks and troughs. And this is where time of use tariffs are going to become very key. So for instance, in my own home, between midnight and 5 a.m., I pay 9p a kilowatt hour for electricity. And outside of that time period, I pay 30p a kilowatt hour. So if I was to tell my Mixergy tank, this is what I have access to, what the Mixergy tank will do is it will understand how much hot water I need, understand the cheap periods, and it will load shift. So it will ensure that all of my hot water is heated in the cheapest part of the day for my pocket, but also the cheapest part, often, as you can see from the graph, corresponds with having the lowest carbon impact. And that's going to become very key for us to achieve net zero by 2050. So to bring this to life a little bit more, here's a live example of a Mixergy tank. So we have the 24-hour time period, the power consumed, and this side here has the temperature of the water and also what we call the state of charge. So the important ones to look here is the orange one. So this is what we call the state of charge. So essentially at about 2 a.m., the tank had a 30% charge. What we then have is the price of electricity. Each of these pink lines with the green outline tells me that the immersion heater was turned on. So what you can see is between 2 a.m. and 5 a.m., this tank has turned itself on when the price of electricity plummeted to a negative. When the price went to a positive, it turned itself on, to a negative, turned on, and so on. So essentially, between 2 and 5, when I assume this customer was in bed asleep, they basically went from a 30% charge to a 95% charge. Their tank consumed 5.3 kilowatt hours of energy. However, they got paid for taking that energy because what they did was they helped balance the grid. So it's more cost effective to give everybody a little bit of energy for free and to pay us a couple of quid than it is to essentially turn off all these wind turbines and all these assets and just basically waste it. And again, this is going to become very, very key if us trying to achieve net zero. As that 40% gas that we currently utilize for gas for our electricity hopefully dwindles down to nothing, there's going to be more wind, more solar generation coming onto the grid. So the occasions that demand solar response are going to happen are only going to increase. So we have the Mixergy dashboard, which gives us, all the live data. So our tanks are constantly feeding back into this dashboard and giving us, copious amounts of information. We have key portfolios for key clients. So, a particular client will have their dashboard. It will show them collectively what's happening across their whole fleet of tanks. It can also be broken down into a individual tank. So here is an example of a Mixergy tank. So again, we have the familiar 24-hour time period and the state of charge and the temperatures. What we also have is we can actually measure. So the dark blue is the incoming cold temperature. The teal is excess solar generation. So this is generation that the household is not using, and without it being stored in either a thermal battery or some other battery like an EV, for example, would just go back to the grid. We can actually also measure the whole house electrical usage, which is the grey line. The orange, like I explained previously, is what we call the state of charge. So, if you see a gradual decline like that, that is natural heat loss. When you see a sudden plummet, that's where someone's using hot water. And if the line is increasing, that's clearly when it's been reheated. These pink lines here tell me it's the primary heat source that's heating the tank. And the black and the blue, are essentially the temperature points within the tank. So the important thing to understand here is basically, give or take about 9 o'clock in the morning, this tank had about a 28% charge. And as we can see, when the solar generation was obviously doing what it was doing, we went from a, give or take, 28% charge to about just beyond 5 o'clock to about a 90% charge. And then as you can then see, the solar has then flatlined. However, that was enough generation this day to cover this evening usage. If we then fast forward to the next day, it actually then prevented the primary heat source from having to come on. We can see that this tank consumed 9.74 kilowatt hours of energy, and 9.73 of that was all provided by the sun. So they're not imported any energy, so they've not imported an energy bill, and they've not imported any carbon. As I said, if we go back if we go forward to the next day, you can see we've heated enough the previous day to cover the previous evening usage and this morning usage. So again, we've prevented the primary heat source from coming on. The tank has then done exactly the same thing on the 14th. This product, for about 6 or 7 days, essentially did not import any energy because it was all provided by the sun. The newer version of the Mixergy product is what we call the IHP. So this is the integrated heat pump cylinder. So fundamentally, from here down is Mixergy. So it's everything I've just discussed. The primary difference being it has a heat pump that's integrated onto it. So it's not going to be heated by an external heat pump or gas or oil water, for example. What we have is we have a modular design. So the actual tank and the head unit can be separated for ease of installation and maintenance. Our tanks also range in various sizes. So what we see in the market is generally our competitors tend to have very large volumes, so circa 250 liters, 270, nearly 300 liters, and they have very slow reheat periods. Sometimes in excess of 10 hours to heat the whole tank. The Mixergy range size goes from 125 liters all the way up to 250 liters, and we also have the fastest reheat periods on the market. We are also able to volumetrically heat as well. So if you was, for instance, to use your whole tank of hot water, but you just needed a certain amount, we could deliver usable hot water in as quickly as 30 minutes. Because of all of this, the Mixergy tank performs very, very well in the world of SAP, which is obviously going to be evolving into the home energy model. I'm not going to go into this too much because, as I'm sure we're all probably aware, the SAP algorithm and HEM is obviously very detailed. However, in very simple terms, if you use the model Mixergy compared to a traditional cylinder, we will have a best benefit. And there's me. Thank you very much for your time.
Well, thank you very much, Peter, for joining us at Show Home Live and for sharing that very informative presentation. It's a lot of information to digest, but incredibly interesting. I'm curious to know what has been the general feedback, a response from homeowners so far in terms of how they're adapting to this kind of system.
Yeah, it's quite interesting, really. So, as we are transitioning to more low carbon technologies, our homes are now becoming more complicated. So I've worked on the project with Keepmo, Gidling Green, which is the first at scale private sale homes built to the Future Home Standard, and they consist of a mixture tank, solar PV, underfloor heating, EV, and also a heat pump. Historically, generally, people could just walk straight into a home and essentially very easily figure out how to use hot water and very quickly figure out how to turn the heating on. Going forward, our homes are now becoming a lot more complicated. So there's definitely education that needs to be applied across the whole system. With regards to Mixergy, it is very intuitive. We also have the online training. So we have like online videos where like a step-by-step guide. Often I will do my best to train the contractor, train the sales team, who obviously then hopefully are able to help anyone who moves in. At the point of someone moving in, even if they wasn't still quite sure, we obviously have the Mixergy helpline. And because we can remotely log in and dial into the tanks, someone might inadvertently have applied a certain setting without necessarily understanding it. And we're able to understand that remotely, repair it remotely, and then obviously advise them on perhaps the correct configuration.
Yeah, it definitely sounds like a very efficient and effective system to put in place, and a great way for us to save our energy consumption levels and therefore our costs of living. So just finally, when it comes to the homeowner, they've moved into a new home and they have this water tank, let's say with a heat pump installed. What support is on offer to them if they don't know how to work it, or they want help setting up the scheduling, for example?
Yeah, so again, it goes back to so we do an awful lot of work with the actual developer themselves because historically, generally developers have been selling houses on the fact it's got a nice kitchen, it's got a nice bathroom, or there's a very good school just around the corner. Going forward, I think homeowners are now a lot more in tune with the need to decarbonise, and especially with the energy crisis, they're now a lot more in tune with obviously the potential efficiencies. So for me, it starts at the very beginning, training the contractor, training the sales team, who can obviously then help when someone does move in to understand what they're actually buying. So even those show homes, we can actually set up a dummy app on their sort of iPads, which a lot of them have, or a smartphone, so they can actually show the customer what it looks like and how they can do things. Often show homes would often have a tank actually in there, which is live and working. So again, they can kind of talk through it. But again, we have the mixed user support through online videos. Scan a QR code and it will essentially show you how to set it up. There's also question mark button. So if someone's not quite sure what a particular setting may mean, they can press the question mark and it will essentially give them an abbreviation and a bit of a paragraph onto what it may mean. That can help steer them. And again, if they're still not sure, they can obviously call us, and or we can also assist with that by remotely logging into the tank to see what they have or haven't set.
No, thank you very much. That's very helpful. And thanks again for joining us today at Show Home Live.
Excellent. Thank you very much for your time.